Anjali is going to talk to us about Finn Hill Elementary, Lake Washington School District.
Okay, so this is the Lake Washington School District. It's Finn Hill Junior High School, 130,000 square feet building with 750 students. I just want to give a shout out to the team. Airman Engineer Shane is here today. Colin Porter on the team. We have Chris Duvall here today. Cascade Design Collaborative. Cass is here. And Mohammed's here from SSA. So there's a lot of good team members. And this was an integrated effort. This is overall program diagram of the building. This is going out to bid in a month or so, so it's not hasn't been built yet. You can see classroom pods, electives, commons, making use of this north woods to the north and trying to maximize views there, and also trying to recreate the courtyard of their existing school and that sense of being connected to the outside. So it's a single-story school. So when we started the project, Lake Washington said, we want to be the most efficient district in the state. So it was already, the bar was set high. Everyone is thinking about energy these days. And this presentation will focus on energy. So our challenges were, well, we want a single-story school because we really want to make these connections to the outside. We want students to have that outdoor learning, but that's more envelope to insulate. So how do we deal with that? We try to keep the volumes low and simple, and we make sure that all those outdoor spaces are well used and they're oriented properly. Our second challenge, we don't want just an insulated box. We want glass for daylighting, for views, and for connection to the outdoors. So the concept of that was to maximize our daylighting efficiency, and then, like Philip was talking about, to use triple glazing. For us, we're not using it everywhere. We are analyzing where we need it, and so we're trying to use it selectively. And then finally, we have a shrinking budget and operations and maintenance budget, which I'm sure all of you are familiar with. So how do we deal with that? We try to use fewer moving parts, systems that are easy to maintain to make sure that this stuff stays in building and that that your maintenance doesn't get impacted. So the workhorse of the system, of the heating system, is really different from what you've seen. The workhorse is a heat pump. What we're doing is we're using a modular heat pump system, which, like geothermal, uses, rather than using the earth, uses the air as a heat sink, and that feeds a loop, a pipe loop, which provides the heating. The efficiency of a heat pump can be up to 4 times the energy you put in. If it's really cold outside, the efficiency might go down to, say, 2.5 times. And then in addition to that, we're using VAV boxes where we need them, heat recovery to make sure that we capture all that heat as it's going out. And then rather than using natural ventilation, it's a fully ducted system, so it's mixed mode. We are using, in most places, one set of ductwork to provide your ventilation air, which by adding heat from the heat pump is also providing your heating. So we were able to offset the cost of that by eliminating all the perimeter radiation. So we don't have any baseboard heating anywhere. So that was, so we were able to kind of make those cost trade-offs. In addition to that, we did do an enhanced thermal envelope. Like Philip mentioned, a typical R10 metal stud wall with bats, which you can't do in the city of Seattle per their energy code. 2x6 stud wall with metal studs is about an R10. So you really lose, you lose almost half of your effective R value. So what we decided to do was go with a structural insulated panel for the walls, which is an R22. It's the same thickness of wall. The roof, I think, is an R38. And then what we did was we tried to take advantage of the structural capacity of those SIP panels to space our structure out farther than it typically would. So try to do the cost offsets that way, reduce the amount of steel in the building, reduce the amount of structure, and to use the SIPs to their highest potential. Rather than calling it natural ventilation, we're calling it natural cooling because the ventilation is being done by the mechanical system. Shane tells me that soon, with the new version of ASHRAE, we will not be able to do natural ventilation only through windows. So this is something that might affect all of us. And one of the issues with that is the potential heat loss through the windows if you have natural ventilation. So we're taking a page from Rachel Carson using the red light, green light system, where if the light is green, you can open the window.